This is question 21 from Book 1 based on the 2020 NEC, and this is electricaltime.com. What is the minimum conductor in AWG required for a 120 volt circuit with 8 ohms of resistance impedance that will remain energized for 6 hours at a time? And the answer to this question, just want to take 30 seconds to let you know what we do here at electricaltime.com. We do online electrical classes from the comfort of your home. And then we also have this free service. So if you click on the subscribe for free NEC questions, Monday through Friday, you'll get an NEC code question and an answer sent to your email. All right, so back to our video. Is B, and that's going to be 12AWG. So what I'm going to do when I see a question like this, and I got volts, I've got resistance and ohms, I'm going to think about Ohm's law. All right, so I'm going to write that down, E, I, and R. And you know what? I'm also going to write down pi. So I know what my E is. The E is going to be 120 volts, so I'm going to highlight that over here on both of them. And I know my resistance is 8 ohms, so I'm going to highlight that. So now I can solve for I, which is amps. So I is equal to E divided by R. I is equal to 120 volts divided by 8 ohms. And I is equal to 15 amps. All right, so now I know what I is. I know what I is over here at Ohm's law, and I also know what I is over here at pi. So if I wanted to calculate the watts or the VA, I could, because now I have enough information with the pi formula to calculate that. So you see, these two formulas are interrelated. So when you write one, write the other, and it might help you to, find the answer, a lot quicker. So let's take a look in our book and see how we solve this problem. So eventually we're going to get to Article 310, and that's called Conductors for General Wiring. That's within Chapter 3, Wiring Methods and Materials. And we're going to find Part 3 in Article 310, that's called Installation. And then we're going to find Table 310.16. That is going to be our ampacity table that we're going to be looking at for this exercise. So step 1, let's take a look at Ohm's law. And that's where we have E is equal to I times R, where E is equal to volts, I is equal to amps, and R is equal to resistance. In step number 2, let's rewrite Ohm's law and solve for amps. So I is equal to E divided by R. I is equal to 120 volts divided by 8 ohms. I is equal to 15 amps. Let's take a look at step number 3. A continuous load is defined as the maximum current that can exist for 3 hours or more continuously. Since this circuit will stay energized for 6 hours at a time, it is considered to be a continuous load. We then multiply these amps by 125%, which gives us 18.75 amps. And then we got 15 amps times 125% is equal to 18.75 amps. Okay, step number 4. Let's take a look at Table 310.16, and let's look at the 60 degrees C column for copper. We see that 15 amps is too small. We need a conductor that is rated at least 18.75 amps. The next size conductor gives us 20 amps, and that gives us a 12 AWG conductor, and that is the answer. So the answer is going to be B, 12 AWG, Ohm's law, and that's a continuous load at 125%, Table 310.16. So let's take a look at Ohm's law and see what we got here. So one thing I want to mention is the NFPA link, a fantastic app. Go check it out. It's at nfpa.org. And I think they give you like a 2-week free trial to go check it out. It's like having the code book on your cell phone. It's really cool. So we're going to be looking at the 60 degrees C column over here, and we're going to need to find a conductor that's good for at least 18.75 amps. And we see we got 20 amps, and that's going to be the 12 AWG conductor. And again, that's the answer to this question.